My name is Bunda. Welcome to my YouTube channel, and in this video I'm going to talk about clean architecture in Android and iOS development. You'll learn about clean architecture, loose coupling, designing beautiful, maintainable, and testable code. So just like a building architect maps out a building space into different levels, rooms, and exits, so do we layer our applications into different complete and loosely elegant systems. What I mean by loosely elegant systems, these are systems that you can essentially swap out different components because your system is not completely tied to particular rules within your code base, but rather than conforms to certain contracts, allowing different classes within your code base to essentially conform to those contracts and allowing you to essentially swap out these components, making your system more loosely coupled. Software architecture is all about separation of concerns. And what separation of concerns is, breaking up your code into different parts that perform specific functionality. For example, you would have a data access layer, you would have a business logic layer, you would have a data persistence layer. All these layers are essentially considered as concerns. And whenever you separate out your concerns, you create a modular system. This essentially allows you to create a program that has easy data flow and is easier to test and maintain. So at this point, you should be thinking of yourself as an architect. And we as architects have various types of architectural patterns to achieve said separation. Most common in mobile development are MVC, MVP, MVVM, Viper, composable, and clean architecture. All these patterns aim to achieve the same goal. Though varying approach and naming all attempt to achieve separation of concerns. Clean architecture is a pattern manifested into this world or brought by none other than Uncle Bob, which is Robert C. Martin. And within clean architecture, as you can see in this diagram over here, you have rings, and each ring essentially represents a layer within your application. The outermost layers are your systems and frameworks, whereas your innermost layers are rules and policies of your application. And the main concept within clean architecture is your source dependencies should point inwards, which means for each outer layer should only reference the most closest inner layer to itself, whereas for each inner layer, it should not reference or know anything in an outer layer. So this could be anything from functions, classes, or variables. Your inner layers are encapsulated within themselves. So we have entities. These are your core business objects. Logic, and they also contain rules and policies of your application. So these can be models, these can be functions, and these can be classes. But these are essentially your innermost source dependencies. And then you have use cases. So use cases transform your data that's most relevant from your entities to the next layer, right? Which is interface adapters. In mobile, we don't use interface adapters, but this layer would be the view model layer. And use cases essentially allow you to put data from your entities layer over onto your view model layer and does some data conversion for the data that's most relevant in your view model layer. And then your view model layer essentially allows you to now talk to the external layer of your project, which would be either your UI layer, or it would be a database, or whatever front end you want to incorporate your core business logic with. So why clean architecture? Firstly, because one, it's platform agnostic. So for myself, I'm a full stack mobile developer and I work across the stack. So I'm building Android and I'm building iOS. And I'm also working on, sometimes I'm doing some backend stuff too. And I wanted to find an architectural pattern that was platform agnostic. Because I could say use MVVM for Android and iOS, and I actually do that. I use a mix of clean architecture with MVVM for Android and iOS, and then for usually other platforms it's just really just clean architecture. But all that to say is, I wanted to find an architectural pattern that was platform agnostic and that I can use across platforms. Because, for example, take Viper architecture that's common in iOS, whereas composable architecture is available. Like, I've seen some proponents for composable architecture in Swift, but majority of that I see over on the Android side. The second reason why you should go with clean architecture is it's independent of UI. So you can easily swap out your UI. Say, for example, in mobile, you can swap out your UI framework that you're using for XML to Jetpack Compose on Android, or you can swap out UIKit to Swift UI on iOS and still have your application perform and run the exact same way because your core business logic does not change. The third additional benefit to clean architecture is testability, meaning you can easily test your core business logic, meaning your core business logic is separated from your UI logic and knows nothing of it. So you can really write these isolated tests on your business logic, and then you can write UI tests in whatever framework that you do decide to write your UI in. I'm gonna go over this multi-platform payments and video streaming app for Android and iOS. I'm using KMM, and this essentially allows me to have a monolith type of project where I have the Android, the iOS, and a shared SDK in which that contains the core business logic that I share across Android and iOS. In this case, Android and iOS are just screens, and all my core business logic is encapsulated within the SDK. So over on Android, I have individual packages for different screens. I separate out by screen, by components, and by feature. So for example, for the screens, I have the screen and I have a view model. The presentation layer represents the two most outer layers of the circles, which are your UI and your interface adapters. We're not using interface adapters, or an equivalent would be the view model. So the view model essentially has one dependency, which is a controller, and the controller is just a grouping of use cases. So the controllers essentially allow me to have use cases to get data, to post data, and I just group all related use cases into a controller. This structure is the same across Android and iOS. I have the exact same naming. In the presentation layer, you go down to the same screen, and you have the screen and its view model and a controller within the view model. And the view model is taking a controller that's a grouping of use cases that the screen can essentially perform on the UI. So down to the last two layers of the circle, we have, and these are within the SDK. So the SDK is where my core business logic is, and this would be where my use cases and my entities are. So my use cases get the data from the entities layer and provide it to the next layer, which would be the view model layer, right? And within this layer, you can think of the entities layer as the domain layer. So I've got the core business objects that I do use throughout the app, and then I have contracts. So these are interfaces. I have repositories and I have controllers, and these are all just interfaces that I depend upon within the actual code base. So my whole code base depends upon abstractions, and then during runtime, with the help of dependency injection, I provide the actual concrete implementation for that conforms to that particular interface. Here is where I define the use cases. They're just classes essentially that perform data, and for the most part, I created the backend, so I did a lot of data mapping and data transformation over there to make it more relevant. But there's two cases where I do need to do some post processing on the data. For example, events within the UI, I get all the events from the backend. So I just get a list of all the events, and what I do within the use case layer is I group all these events by the month that they start in. So that way in the UI layer, instead of just getting an array of events, I get an array of grouped events grouped by their month that they belong within. And that's the transformation I changed from an event to an event group. This is essentially how I have implemented clean architecture in this project. So my entities and use case layer are within the SDK, and then my interface adapters and UI are defined within the platform they belong to. All in all, the dependency rule and separation of concerns are the core of software architecture. By adhering to these rules, you set yourself up to create a system that's easily testable, loosely coupled, and it makes your system more adaptable. There's always shiny new tools that might grip your heart. By properly architecting your system, you can easily swap out these components, and it makes your life so much easier. So happy learnings and all the best. Link to the article will be down in the description. I'd really appreciate it if you gave this video a thumbs up and if you subscribed. Thank you.